is line integrals of a scalar field. So take note of the phrase of a scalar field. So line integrals of a scalar field, because in the future we're going to discuss line integrals of a vector field. So pero ngayong araw ang gusto lang natin is of a scalar field. So today is May 26. Okay, inayos ko lang yung petsa. Okay, punta tayo dun sa first question natin. So, let us evaluate this line integral. This is your scalar field over your curve C, which is parameterized by R. And what do we mean by ds? D tapos small s. It means integrate with respect to arc length. Okay, small letter s ha, kasi in the future meron tayong capital S, which is integration with respect to surface naman yun. So ngayon nasa arc length pa lang tayo, kaya ang tawag dito line integrals. So paano ine-evaluate ito? Okay, so anong sabi ng ating rule for that? So ito yung rule natin. So, yung XYZ mo will come from your curve C. So, this is the X component, Y component, Z component. So, in your scalar field, you replace XYZ by the XYZ components respectively of your curve C. Kaya siya naging ganito. And then, replace DS by the magnitude of R prime dt para maging ordinary integral na lang siya. And then, integrate it from T1 to T2, yung limits nung T mo. So, yung T1, dun yung initial T value ng iyong curve. T2, that is the terminal T value for your curve. Okay? So, ganun lang yung gagawin natin. So, let us write this curve in component form para mas madali siyang makita. So, this is 2 cosine T, 2 sine T, and T. So, this will become your x, y, and z in your scalar field. So, replace x, y, z by those expressions. That is equal to e raised to negative t divided by 2 cosine square t plus 2 sine t square. Okay, so tapos na tayo sa part na ito. While ds becomes magnitude of r prime dt. So we need r prime first. I need space. R prime of t is, get the derivative of r, which is negative 2 sine t, comma, 2 cos t, comma, 1. And then its magnitude. Yun yung kailangan natin, the magnitude. Square root of negative 2 sine t square plus 2 cos t square plus 1 square, sum of the squares of the components, and then square root. So you get square root of 4 sine square t plus 4 cosine square t plus 1. But this thing is just 4, right? Because sine square plus cosine square is 1. So you get square root of 4 plus 1, which is square root of 5. And ds, sabi natin, is magnitude of r prime of t dt. So this one becomes square root of 5 dt. And your limits of integration, your t values, naging t na siya, no? Line integral, magiging usual integral lang. Ganun lang basically yung ginagawa natin. your t runs from 0 to 2 pi. Okay, so compute na natin ito. 0 to 2 pi ng square root of 5 e raised to negative t dt divided by, ano ito? This is 4 cosine square t plus 4 sine square t, which is, if you factor out 4, you get 4 times 1 or 4. So, ayan, ano integral ng e raised to negative t? You get negative e raised to negative t. And then, plug in negative e raised to negative 2 pi minus negative e raised to negative 0, or square root ng 5/4 negative e raised to negative 2 pi plus e raised to 0 is 1. So the value of that line integral is given by this. Okay. May questions for that item? Segwayan ko lang to ng ano. Ang dami kasi nating integrals na inaral, no? Para lang magkaroon tayo ng ano, ng awareness. Char. Awareness. Etong integral na to, the usual integral that we know, the single integral, we learned it from Math 21. Right? And yung pag-evaluate nito, or principles of integral evaluation, sa tutunan in Math 22. But in Math 23, we have a double integral. And we have the triple integral, nakakaaral lang natin. Tama. Tapos yung dalawang yan, ginagawa nating iterated integral. Right? So, pwede siyang maging ganyan, f of xy. Tapos, may mga something ka dyan. Tapos, limits of integration. And then, pwedeng triple integral. Tapos, may mga limits of integration ka dyan. Okay? Pag naging iterated integral na, we integrate from inside to outside. Diba ganun yung usual na ginagawa natin? We start from here, tapos palabas siya ng palabas. But the point here is, meron kang abstract integral na ginagawa mo lang siyang integrals na from Math 21. And in this case, itong iterated integral, paulit-ulit lang to na integral from Math 21. So, ganun lang din yung ginagawa natin sa line integrals. Ito yung abstract definition, or yung abstract way of writing it. Tapos, ito yung katumbas niya sa Math 21 na integral natin. Nagiging ordinary integral na lang siya. So, ganun lang yung gagawin natin sa lahat ng mga integral, kahit anong line integral pa yan. So, kahit line integral of a vector field pa yan, which is our next lesson, ganun ulit. Ko-convert lang ulit natin siya sa ordinary integral, kahit surface integral pa yan. Okay? Okay, so proceed na tayo dun sa next example natin. So, give the area of the surface that extends upward from the line segment from 1, 1 to 2, 3 on the xy plane to this surface. Provide a sketch of the surface. So, bago natin sagutin yung question at yung concept, i-recall yung concept behind it, let us draw the surface first. Yung surface na gusto nating kuhanan ng surface area. So, let's say this is your XYZ plane. or XYZ axis. So, etong surface na to is, that is actually a what? Of course, it's a quadric because it is a degree 2 polynomial in XYZ. But what type of quadric? Pag pinalitan mo ng values sa itong mga y, you get parabolas. If you treat x as a constant or you replace x by some number, you get parabola. If you replace z by some number, you will get two intersecting lines or hyperbola. So, anong quadric iyon? Ano sa tingin ninyo? Hey. Habaan natin. Okay. That quadric is, this is from Math 22, this is a hyperbolic paraboloid. Tapos anong graph ng hyperbolic? Ito yung ayaw nyong i-graph sa Math 22 eh. Pag ganyan, diba? Na all, magaling mag-drawing. Ganyan yung itsura nun, diba? Or yung iba ang pagkakadrawing nila, ito yung na-emphasize nila. Okay, ganyan nila dinodrawing. Okay, pero ang idodrawing ko yung nasa bandang ano lang, positive y-axis. So, let us draw. Okay, anong trace niyan sa xy plane? So, isa-set mo si z equal to 0, you get y square minus x square is 0, or y square equal to x square, or x equal to plus minus y. So, these are two intersecting lines na x equal to y tsaka x equal to negative y. So, let's say yung isa pag ganito, and then the other one,
In fairness.
so ayan yan. Okay? Yan yung hyperbolic paraboloid natin na portion lang yung drawing ko na nasa positive y part. Okay? And then anong gusto mo? Yung surface mo is the one that extends upward from the line segment from 1, 1 to 2, 3 on the xy plane. But 1, 1 is on this line, x equal to y. This is x equal to y. So, somewhere andyan si 1, 1. And si 2, 3, somewhere nandito si 2, 3, siguro. Okay. So, this is your line segment. Yan yung trip mong line segment. And if you extend that upward, yung surface yung makukuha mo. So, extend upward, tatama dun sa hyperbolic paraboloid mo. Ito wala kasi andito yan, nag-intersect yung line na yan doon sa xy plane. So, something pa curve. So, that pink surface is yung gusto nating surface na kuhanan ng area. So, itong i-highlight ko ng violet, that is our C. Okay, so nagigets nyo na ba ano yung tanong? So, ito yung line segment from 1, 1 to 2, 3. You extend it upward. Ito yung makukuha nyo. So, yung bubungan niya, bubong, or the ceiling, is the hyperbolic paraboloid. And we have a formula for that kung paano makukuha yung surface area nito. Nandoon sa ating recall. Okay, so whenever you see this line integral of a scalar field in two variables, thus you are integrating along C with respect to the arc length. Of course, yung formula same pa rin. You replace x and y by the x and y components of your curve respectively. And then you replace ds by r prime, magnitude of r prime of t dt. And then integrate from t1 to t2. Okay, so ito yung isa yung interpretation. Itong nasa second bullet natin. Itong binabox ko. So you can interpret this one as the area of the surface that extends upward from C. This is your C. Extend upward on the xy plane. Your C is on the xy plane to the surface z equal to f of xy. Ito yung z equal to f of xy mo. Provided that z equal to f of xy is non-negative if you substitute all the points on your curve. So, basically, ganito yung itsura niya. Mukha siyang kurtina. So, naghahanap ka ng area ng kurtina. And another interpretation of this line integral is that, or is, the mass of a wire. So, hindi mo nakikita yung f of x kapag ang interpretation mo is the mass. So, ito, kuwari, ito yung wire mo on the xy plane which follows the path of C. So, this line integral is the mass of the wire along C with density function f of xy for xy in C. So, itong line integral na to has at least two interpretations in our class. Or, sige, kahit ito na lang yung aralin niyo na interpretation. So, yung una, area ng curtain. Pangalawa, density ng wire na nasa xy plane. Okay? So, dito sa problem na to, sa number 2, to get the area of this, pinapahanap niya lang yung line integral. So, area is equal to the line integral along C nitong z equal to f of xy. But that z equal to f of xy is y square minus x square. With respect to arc length. Okay? So, paano ba iyan? Sige, gawin natin para magawa natin to, we need RC. We need to parameterize C. So, how do you parameterize this? So, ano yung recall dito? Baka hindi na naaalala. So, parameterization of a line segment from x1, y1 to x2, y2. So, pwede mong gawing kung gusto mo sige, parametric muna tayo. So, initial point plus x2 minus x1t, y2 minus y1t, where y is y tuloy, where t is between 0 to 1. Your parameter is t. Or kung gusto nyo naka-vector notation, gagawin nyo lang x component yan. Tama. Y1. And your t is between 0 to 1. So, yun yung parameterization. Okay? So, yung violet na curve natin, violet na curve. This is our x1, y1, x2, y2. So, apply natin ito. Initial point 1, 1. 2 minus 1 is 1. Comma. 3 minus 2 is 2. And then your t ranges from 0 to 1. Ayan, mako-compute na natin yung area. Okay, so the area now is equal to this is your x, this is your y. Yung xy mo manggagaling kay c, but this is c, your r. So 1 plus 2t square minus square of this. And then our ds, how do you compute ds? ds is magnitude ng r prime dt. Ano yung r prime natin? So, babalikan natin ito, no? I need space. Dilitan ko lang ito. So, r prime of t dt, r prime of t is, derivative of this with respect to t is 1, 2. And its magnitude is square root of 1 square plus 2 square is square root of 5. So, balik tayo dito sa kino-compute natin. So, sa ds na tayo. Magnitude ng r prime is square root of 5 dt. At yung bounds natin, kung ano yung bounds ng t, from 0 to 1. Okay? Tas ano na lang ito, ordinaryong integral. So, ano na yan? 0 to 1, 4t square plus 4t plus 1 minus t square plus 2t plus 1. Square root of 5 lalabas ko na. Simplify nga natin. 3t square. This minus this is 2t. Square root of 5, integrate natin na. So, t cube plus t square. T from 0 to 1. Or plug in natin yung mga t, no? When t is 1, we get 1 plus 1 which is 2. Minus when t is 0, 0 plus 0 is 0. So, the area is 2 square root of 5 square units. Okay. Sige, lagyan natin square units. I-ano nga natin to, ikahon natin to. Para hindi halo-halong kalama yung ginagawa natin. Okay, questions for this item? Sa kabilang class actually medyo namali nga ako ng drawing, no? So, nausog ko yung 1-1. So, nagawa akong drawing sa kanila ganito. Although hindi naman magbabago yung sagot. Ang mahalaga nasa loob yung nasa loob yung lines. Ganyan yung nagawa ko sa kanila. Anyway, guide lang naman yung drawing, no? Pero ito yung mas accurate drawing niya. Yung 1-1 nandoon sa line na ito. Isa kanila sa loob ko nalagay. Pero yung makukuha mong area, same pa rin. 2 square root of 5. Okay. Number 3 na tayo. Ayusin ko lang yung yung page. Okay, number 3. Find the mass of a thin wire shaped in the form of the curve. This is your curve. If the density function is proportional to the distance above the xy plane. So your curve here is a three-dimensional curve. So meron tayong recall for that. So yun yung counterpart nito. If your scalar field is in three variables. So ganun ulit, you have your wire na fina-follow yung shape nung curve C na um, nasa XYZ plane. XYZ plane, nasa R cube. Okay? And suppose, if we assume that the density at a point XYZ on the wire is f of XYZ, then you can compute the mass of the wire, which is given by the line integral of f along C. Okay? Ganun lang ulit, you replace XYZ by the XYZ components of your R, ds by the magnitude of R prime of t dt, and your bounds t1 up to t2. Gawin natin yung huling example natin. Okay? So, yung curve natin, yung C, sulat natin in component form. So, the x component is 2t, the y component is ln of t, the z component is 4 square root of t, where your t is between 1 to 4. So, ang problema na lang natin ngayon is the density function kasi ang mass is equal to the line integral of the density f x y z with respect to the arc length along C. Okay, so paano natin kukuhanin yung density function? So, yung f of x, y, z, which is your density function, sabi dito, it is proportional to the distance above the xy plane. So, distance of your point above the xy plane. So, if this is your xyz plane, and you have a point, of course, yung point na yun nandun sa curve. So, yung density mo is a constant times this length, which is z. Okay? So, density function is equal to a constant times yung distance sa xy plane, which is z. Okay? May questions ba doon? Because the distance of this point from the xy plane is z. Okay? Yung height bale. Tama sa z yun. So, the mass is equal to the line integral of a constant times z along C. Okay, so plug in na natin yung values. K times z. Z is 4 square root of t. ds is magnitude ng r prime of t dt. So, let us compute for r prime of t. Gusto ko violet. 1 over t 4 over 2 square root of t, which is 2 over square root of t. And what is the magnitude? Square root of Square, square, square. 4 plus 1 over t square plus 4 over t. Combine natin na sa single fraction, ha? Ano ba ito? 4t square plus 1 plus 4t. Usog natin to kasi kailangan natin ng espasyo. Mukhang suspicious to, no? Mukhang masisimplify pa into 2t plus 1 over t square. Tama. Ito is 2t plus 1 square. This is t square. So, if you get the square root of something na naka-square, you get its absolute value. Recall, square root ng a square is equal to absolute value ng a for all a na real numbers. Okay. So, balik tayo dito sa mass. Here. So, ang mass mo ay ito kz, ds is magnitude ng r prime, which is this. Dt. And your limits of integration, yung limits ni t, which is from 1 to 4. And then, solve na lang ito ng normal. Nagpapa-complicate lang siguro dito is the absolute value. Para makapag-decide ka, sabi sa Math 21, you look at the limits of integration. So, the limits of integration for t is from 1 to 4. But as you can observe, 2t plus 1, it's positive. It's if t is from 1 to 4. T is positive if t is from 1 to 4. So, if you divide two positive numbers, you get a positive number. And you get its absolute value, siya pa rin yung makukuha mo. So, you can get rid of that absolute value. So, the reason for this is since 2t plus 1 over t is positive 4, values of t from 1 to 4. Simplify na natin ito. 4k. This divided by this is t raised to negative 1/2. Ginawa ko exponential kasi mag-i-integrate tayo. So, pull out ko yung 4k. It's just a constant. Distribute. So, you get 2t raised to 1/2 plus t raised to negative 1/2 dt integrate 2t plus 1 is 1/2 plus 1 is 3 over 2 times 2/3 plus t raised to, you add 1 to negative 1/2, you get 1/2. Evaluate from 1 to 4. So, 4k, plug in 4, t equal to 4. 4 raised to 2, 4 raised to 1/2 is 2. Raised to 3 is 8. Times 432. And then divided by 3. Plus 4 raised to 1/2 is 2. Times 2 is 4. Replace t by 1, you will get 4/3 plus 2, which is 4k times, is it 28 over 3 plus 2, which is 4k times 28 plus 6 over 3, 4k times 34 over 3, Ilan? 34 times 3, 120, 136 over 3. Okay. So, this is the mass of the wire. So, whatever that K is, yung constant of proportionality ninyo. Questions?